Welcome everyone. The question asks us to find the value of a raised to power 2000 plus a raised to power 2020 plus 1 if a raised to power 4 plus a raised to power 3 plus a square plus a plus 1 equals to 0. So what the question is saying is that given a raised to power 4, that is this equation, so then we are to obtain the value of this guy. It is very simple. How do you do this? So although it looks complicated. So suppose we were given our a as a single value. Maybe instead of this equation, I just have my a to be 3. Then this is simpler. I can just substitute the value of a to be 3 here. Then I have 3 raised to power 2000 plus 3 raised to power 2020 plus 1. Then I simplify further to have that. But no, so we were not given, the value of a. Rather, we were given as an equation, a quadratic equation, that is an equation with degree 4. So also it might also be simpler to solve if a could be obtained from a linear equation. Maybe instead of this cumbersome equation, I have a plus 1 equals 0. So then I know at the end of the day, I can quickly find the value of my a by making a the subject of the formula here. So then my a is equal to minus 1. Then I can just substitute the value of minus 1. Then I put it here. I have minus 1 raised to power 2000. So that is not so. Also, it is not a quadratic equation. We can easily solve maybe by our factorization method or by the means of your quadratic formula. So how do you now solve this? Also, this is a polynomial. I said the other time it's a quadratic polynomial. Indeed, it has, a degree 4. And don't forget, from one of the principles in polynomial is that when you have an equation of degree n, then you are going to have what? N root. You understand that one? So what that is saying in essence is that when you have an equation of degree 4 like this, then we are going to have, a 4 root, that is 4 values of a that is going to satisfy this equation. But you will see that before you can find this, all these values of a, before you can obtain all these 4 roots, it is cumbersome. You cannot find it easily. One of the ways you can be thinking of is to use what we call a rational roots test. I hope you understand what we call rational roots test. Rational roots test, or you can say rational roots theorem. Or theorem. So this is one of the theorem in polynomial. What the theorem is saying is that for any polynomial, maybe I should write it down. So for any polynomial with integer coefficient, for any polynomial with integer coefficient, what do I mean by that? Let's say, for example, you have like, let me give you this kind of polynomial. So maybe when you have 2x raised to power 3 plus 7x squared minus 7s minus 3 is equal to 0. So this is a polynomial. Indeed, all the coefficients are integers. What are integers? Don't forget, in my previous video, integers, I define it as the what? The set of all positive numbers, negative numbers, and 0. You understand now? So when you have all your positive, you have a polynomial with integer coefficient, then what rational root theorem is saying is that, so then you are going to have the possible rational number you are going to have, so will be plus or minus. So that is the set of factors of the constant here. You understand now? That is the factor of the constant divided by the factors of what? So the factors of the leading coefficient. So the factor of the leading coefficient. So what I'm trying to say in essence is that when you have an equation, you can have many roots. Indeed, you can have a rational root. So what do I mean by rational root? That is when you have something as integers or fraction or even decimal. You understand now? You can write them as p divided by q, where your q is what? Is a number not equals to 0. You understand now? So then you can still have it as what? Irrational number. Irrational number when you have, your number in terms of radical. Why what you have in this radical is not a perfect square. So I have videos on that. You can go and watch my video on sort. In fact, you can still have a complex root. You can have different types of roots. You can have a complex root. You understand now? So that is when you have, your root as a complex number. When you say complex number, that is, you can have it as a plus bi, where your a is real, so it's a real number, and your b is what? Imaginary number. So what that theorem is now saying is that when you now have like a polynomial like this, for any polynomial with integer coefficient like you have, then the possible rational root you can have in that particular equation, so the only possible rational root you can have, so are what? The set of, you have plus or minus. When you say something is a factor, it can either be the positive of that number or negative number. You understand now? So when I say factors, factors are those number that can go in that number, that is number that can divide a number. So the factors of 4 are 1, 2, 4, because 1, 2, 4 can go in 4. So you can use those numbers to divide 4. So in essence, 5 is not a factor of 4 because 5 cannot divide what? 4. I hope you understand now. So, but all these factors, for example, when I say 4, I said 1, 2, 3, 1, 2, and 4, they are the factors. Indeed, so they are either positive or negative. So positive 1 is a factor of 4, likewise negative 1 is also a factor of 4. So then what the theorem is saying is that, the possible rational root you are going to have, so for example, for this polynomial is what? So is the factors of what? Let me just delete this. Let's say, let me write this guy again. Maybe you have 3 s raised to power 3 plus 7s squared minus 2s minus 4 is equal to 0. So then the possible rational number, rational roots of this polynomial is nothing but plus or minus factors of constant, that is the factors of this guy, so which is a constant. I hope you understand what I'm trying to say. Then divided by plus or minus what? Plus or minus factors of the leading coefficient. Plus or minus factors of the leading coefficient. In essence, so if you want to know the possible rational roots in this equation, so then it's going to be what? Plus or minus, they are going to be plus or minus factors of, what is our constant here? Factors of 4, then divided by what? Plus or minus factors of what? So factors of the leading coefficient, which is 3. And we know factors of 4 are what? What are the factors of 4? So factors of 4 are 1, 2, and 4 itself. Likewise, factors of 3 are what? 1 and 3. So then when you want to know the possible rational roots here, so then you are going to have factors of 4. That's going to be plus or minus 1. So then plus or minus 2, plus or minus 4. Then maybe you can write it as a set divided by plus or minus 1. So let me write it together. Plus or minus 1 and plus or minus 3. You understand now? Then you are now going to take them one by one. So for example now, I can have I mean the possible rational roots can now be what? I can have 1 plus 1. You understand now? I can have 1 divided by 1, sorry. Then I can also have plus or minus 1 divided by 3, the second one, because we want to know the possible number. Then I can still have plus or minus 2 divided by 1. I can still have plus or minus 2 divided by 3. I can still have plus or minus 4 divided by 1, then plus or minus 4 divided by 3. So then the possible roots of this polynomial are now going to be what? Plus or minus 1, plus or minus 1 over 3, because it's also a rational number. 1 over 3 is a rational number. Plus or minus 2, plus or minus 2 over 3, plus or minus 4, and plus or minus 4 over 3. And you can try it out. So if you check it out, let us check whether this satisfy it. You say something is a factor. I mean, you can say one is a factor of this polynomial, is a factor of the polynomial f of s. Let's say that is an f of s. Don't forget your factor law. When you say something is a factor of f of s, let's say this is an f of s. So if this is an f of s, it means 1 is going to be a factor of this one. You understand now? So if what? Or let me just say, you can say s minus 1 is a factor of this if f of 1 is equal to 0. I hope you understand now. So that is, you put the value of 1 here and you have it to be 0, then you are going to have a factor. Let's try it. This is going to give me 3 times 1 raised by 3 plus 7 times 1 squared minus 2 times 1 minus 4. This is going to be 3. So 3 plus 7, that's going to give you what? So that's going to give me what? Let me check it again. So this is 1, 3, right? So 3 plus 7, so 3 plus 7 will give me 10. So 10 minus 2, that is 8. So 8 minus 4, so that is what? That is 4. That is not true. Okay, let us try minus 1, whether that is going to work. Okay, if you try minus 1, this is going to give me what? So 3 into minus 1 raised by 3, right? Plus 7 minus 1 squared minus 2 into minus 1 minus 4. And this is going to give me what? Minus 1. Minus 1 times 3. So that is minus 3 plus 7. So plus 2 minus 4. You understand now? So this will give me 4. This is not also 0. Okay, now let us try 2. What if you try 2? So 2 raised by 3 here is what? 2 raised by 3 will give me what? 2 raised by 3 is 8. 8 times 3 is 24. So then you have 24 plus, 2 square is 4, right? 4 times 7, that will give me what? That will give me 28. So then you will see that this is not also not equal to 0. Yeah, but when you try for negative 2, when you try it for negative 2 now, I'm going to have 3 into minus 2 raised by 3, right? So then plus 7 into what? Negative 2 raised by 2 minus 2 into minus 2 plus 4. Minus 4, sorry. Minus 4. You can see that this will give you minus times minus. This is plus 4 minus 4. This gives 0. And this will give you minus 8 times 3. That's 24. I hope you understand now. So that's 24. And this one will give me what? Minus 2 squared, that is 4. And 4 times 7, that is 28. So that is 28. So this will give me minus 24 plus 28. That is not true as well. Okay, now you check with negative 1 over 3 too. I think that should be true. So if you check 1 over 3, then I'm going to have, let me just clear this so that we can see it properly. So I just want to show you that one of all these possible rational number will be one of the root. Okay, let us try it. That is 3 into 1 divided by 3 raised to power 3 plus 7 into 1 divided by 3 squared minus 2 1 over 3 minus 4. This will be 3 multiplied by 1 over 27 plus 7 times 1 over 9 minus 2 over 3 minus 4. So that is 1 over 9 plus 7 over 9 minus 2. Let me write it very well and even clean this guy. So you have 1 over 9 plus 7 divided by 9 minus 2 divided by 3 minus 4. Okay, let me find the LCM. My LCM will be 9. This is 1 plus 7 minus 6. I hope you understand now. So minus 6, and this will be what? Minus 36. You understand now? So this is 8. That's also not equal to 0. So you try it with -3. Let's say if you try it with -3, it's going to work. But what the law is saying, because of the time, is that, so if you want to know one of the root, if you check one of these, the possible rational root for this polynomial will be here if it have. You understand now? That does not mean that polynomial, since I take it from my head, that does not mean it will have a rational root. But if it has a rational root, then definitely the root will be from here. So if that is cleared, then if you now come back to our question, we have a raised to power 4 plus a raised to power 3 plus a raised to power 2 plus a plus 1 is equal to 0. So if you want to use, if you want to find the possible rational root here, let's see if we are going to find it. Then that's going to be plus or minus. What are the factors of constant? 1 divided by the coefficient of the what? Of the leading, the coefficient of the leading the factor of the coefficient of the factor of the leading coefficient. That's also going to be plus or minus 1. Then you are going to have what? 1 plus or minus 1. So okay, let us try it. Is 1 a factor? Let us find f of 1. This is going to be 1 plus 1 plus 1 plus 1 plus 1. That is 5, which is not equal to 0. It is not a factor. Likewise, we find f of minus 1. So then this is going to give me what? 1 minus 1 plus 1 minus 1 plus 1. This is 1, which is also not equal to 0. You understand now? It means this guy, this polynomial does not have what? So does not have, a rational root. I hope you understand now. It means you might not be able to use your polynomial directly. So, okay, let me still copy it here. So if you can't use your polynomial directly now, what are you now going to use? So if I were you, I will just go back to, the value I was asked to find. Look at this one now. I have a raised power 2000 plus a raised power 2020 plus 1. So if you check this carefully, you will see that this a raised power 2000, you can actually rewrite it as what? A raised power 5 divided by 400. Isn't it? Yeah, it is. So likewise, you can as well what? You can as well rewrite a raised power 2020 as what? That's a raised power 4, everything raised power what? I think this will be 402, because if you multiply, is it 402 or 404? Yeah, that should be 404. So that's going to be 404, because 404 times this will give you this guy. So it means if you are able to find this value, if you are able to find the values of what? Of a raised to power 5 from here, you understand now. So then you can definitely or directly, substitute the value of a raised to power 5. But let's see, is it possible for us to find a raised to power 5? Okay, let us think carefully. I have a raised to power 4 plus a raised to power 3 plus a square plus a plus 1 equals to 0. You understand now? So then from here I can obtain my a raised to power 5. So okay, what if I multiply through by a. You know, if I multiply through by a, then I'm going to have what? A raised power 5, because a times a raised power 4 will give me a raised power 5, plus a raised power 4 plus a raised power 3 plus a squared plus a equals to 0. So let's say I call this equation 1, equation 2. You know, I can obtain my a raised power 5 here if I subtract equation 1 from 2. I hope you understand now. So I can just say subtract equation 1 from 2, so that this guy can cancel each other. So if you do that, you will see that a raised power 5, there is nothing like I mean a raised power 5 here, then I'm still going to have like a raised power 5 here. But you have a raised power 4 minus a raised power 4, this guy will cancel this guy, this guy will cancel this guy, this guy will cancel this guy, this cancel this as well. Then what do you have left? Minus 1 equals to what? 0 minus 0 is equal to 0 as well. So from there you can say your a raised power 5 is equal to 0. So, and if your a raised power 5, a raised power 5 is equal to 0 plus 1, so then a raised power 5 is equal to 1. I hope you understand now. So if your a raised power 5 is equal to 1, then you can just go back to your question directly. You understand? So then you now have, if you write the question, you know, we have something of this nature. So we have, let me just copy it here. So we have a raised power 2000, a raised power 2000 plus a raised power 2020 plus 1. So I can rewrite this as indices. Don't forget, from your laws of indices, when you have a raised power m, everything raised power n, you can say it is the same thing as a raised power mn. I hope you understand now. So since we know that our a raised power 5 is equal to 1 from what we've just done, so then you can say a raised power 5, express it as a raised power 5, everything raised power 400. Is that not so? So then plus, because 5 times 400 will later give you this guy back. So then this will give me what? A raised power 5, raised power 4, raised power 404 plus 1. And we know that my what? My a raised power 5 is 1, then I'm going to have 1 multiply a raised power 400 plus 1 raised power 404 plus 1. And 1 raised to power any number will give me 1 again, then I'm going to have 1 plus 1 plus 1, which is equal to 3. Then I say hence a raised power 2000 plus a raised power 2020 plus 1 is equal to 3. I hope you understand now. So this is how you are going to solve this kind of question. You can see it is very simple. If you understand this video, please don't forget to like, subscribe to my channel, and share with your friends so that they can benefit too. I've made several videos. So I have a series for O-level students preparing for WAEC, NECO, and JAMB called SSCE Mathematics from Zero to Guru. So then I have, calculus in 5 minutes, where I discuss, a basic calculus, differentiation, integration. I have complex number the easy way. Then I have a special request series, so whereby you can request for a special video for free. So I'm going to do a video for you if I'm available and I know the question you asked me on mathematics. So thank you so much for your time.